So if Planet 9 is real, where is it? And how does it move? That's the puzzle scientists are racing to solve. Based on gravitational modeling and orbital simulations, Planet 9 can't follow a simple, circular orbit like the planets we know. Such an orbit would bring it too close to the inner solar system, close enough that we would have seen it by now. To remain undetected and yet exert gravitational influence on Ethnos, Planet 9 would need an extremely elongated orbit, an eccentric path that keeps it far away from the Sun for most of its journey. Current models suggest that its perihelion, the point where it comes closest to the Sun, could be between 200 to 300 AU. That's 5 to 7 times farther than Neptune. Its aphelion, the farthest point, could extend as far as 800 to 1,200 AU, an almost unimaginable distance. To put that in perspective, light from the Sun takes just over 8 minutes to reach Earth. It would take light more than a week to reach Planet 9 at its furthest point. Its orbital period, a single year on Planet 9, could last between 10,000 to 20,000 Earth years. Think about that. Entire civilizations could rise and fall on Earth while Planet 9 completes just one trip around the Sun. But distance isn't the only factor. The inclination of its orbit is another key clue. Unlike most planets that orbit in a relatively flat disk, the ecliptic plane, simulations suggest Planet 9's orbit is tilted, 15 to 25 degrees off the ecliptic. This tilt helps explain the odd orientations of certain Ethnos, as well as other distant objects whose orbits appear almost perpendicular to the rest of the solar system. It's as if Planet 9 is dancing to its own rhythm, far above or below the cosmic plane, like a shadow weaving through the edges of the known. Interestingly, these simulations don't just explain what we see. They predict new phenomena. They suggest there should be more objects with highly inclined orbits, ones we haven't yet discovered. If astronomers find more such bodies in the future, it would strengthen the case for Planet 9. But mapping such a planet is anything but easy. Because of its vast distance, Planet 9 would move very slowly across the sky, perhaps only a fraction of an arcsecond per day. That's less than the width of a human hair seen from across a football field. Detecting such slow motion against a dense field of background stars is a daunting task. And then there's the issue of brightness. Planet 9 might be 5 to 10 times the mass of Earth, but that doesn't mean it's bright. If it's a gas giant like Neptune, it would reflect little sunlight at such a distance. It would appear as a faint cold dot, blending in with the darkness, possibly mistaken for a background star. Astronomers have to sift through enormous amounts of data from sky surveys, comparing images taken weeks or months apart, looking for that tiny, deliberate drift that might signal a distant planet on the move. Some sky regions, particularly those near the galactic plane, are filled with billions of stars, making this process even more difficult. It's like trying to find a single snowflake in a blizzard, using only a snapshot of the storm. Still, the search continues. Ground-based telescopes like Subaru in Hawaii have been scanning the sky. Space-based missions like WISE have contributed archival data. And new observatories, such as the Vera C. Rubin Observatory in Chile, are expected to dramatically improve our chances with their wide-field, ultra-sensitive imaging capabilities. Each passing year brings more refinement, better models, smarter algorithms, deeper images, and perhaps the moment when Planet 9 will reveal itself. But what if it doesn't? What if the models are wrong? Could the unusual orbits of ETNOs be explained by something else, like a collective gravitational effect, or even a previously misunderstood aspect of solar system dynamics? That's what makes this such a compelling mystery. We're not just chasing a planet, we're chasing the truth. And in doing so, we're learning how little we truly know about the outermost reaches of our own solar system. In the end, Planet 9 may be real, or it may turn out to be the greatest astronomical red herring of our generation. Either way, The journey to find it is rewriting what we thought we knew about gravity, planets, and the architecture of the Sun's domain.